The topic here is going to be basic helicopter maneuvers. Think of this as your introductory primer to how to use helicopters in nuclear option. We're not going to do a lot of fighting, at least I'm not planning on it so far. The main thing I want to do is show people how to operate a helicopter safely, go over some of the basic flight maneuvers, and we'll see where things go from there. Now, an important thing, one of the first mistakes people make when they fly the helicopter is they dump the collective and wait for it to lift off the ground. Don't do that. When you run the collective at its maximum setting, the torque that the rotor is going to produce is at its highest. And that's going to drive the helicopter into an uncommanded yaw against the direction of torque. The tail rotor usually can't compensate for this, and if you do it in combat, you're going to find your nose coming off of position from where you want to be. It's a bad habit. When you first take off in the helicopter, my recommendation is that you start slow, run the collective up until you feel the helicopter just barely start to lift off the ground. And you can pull the landing gear in as soon as you feel the helicopter start to fly. You do have to make some constant adjustments, small ones, to the collective as you move. But if you do this slowly, you're going to find that the helicopter is much more responsive and easier to control, and that you become a lot more aware of how the little movements affect big changes over time. One of the mistakes people make with the helicopter is that they try to fly it like an airplane. But if you think of it like a fixed wing, you're gonna get yourself in weird situations where you aren't able to do the maneuvers that you need to do. So when you're first starting out, I find that it's good to just get in free flight, take your time, get familiar, and find something that you want to follow. This road on Ignis Archipelago, leading from the forward airfield, is a good way to practice. Just set your navigational disposition over it, and then follow it. Helicopters generate their lift using the rotation of a main rotor. People like to think of this as just a giant fan, but when they picture it, they usually picture a ceiling fan, and that's not what a helicopter main rotor is. Reality behind how helicopters fly is that the actual lifting point of the helicopter's rotor blade is what you are changing as you shift its controls around. When you roll, when you pitch, the angle of attack of each individual rotor blade is being constantly adjusted so that it's never in exactly the same place. As you move your controls, the point at which each rotor blade will generate its maximum lift, this lifting point is what is being manipulated, and it's what allows a helicopter to do things that normal airplanes can't do. So like right now, I am flying sideways slightly as I am cornering so that I'm sliding into my turn. If you get them positioned just right, you can flip them around and you can fly them backwards. Now you notice I gained a whole bunch of altitude right there. Helpful if you've got somebody on your tail, but controlling that is obviously a little difficult in third-person camera. Now you notice two things just happened right there when I tried to spin back around. I got a warning for VRS, and then I started losing altitude. If you look at some clips on YouTube, you can find helicopters and airplanes flying through clouds. You'll get these two vortexes that form above and behind the lifting point. On airplanes, it's the wings, so the vortex forms above and behind the wings. This is what creates turbulence when you're flying around airports. You think of them like horizontal tornadoes, tend to be really close to the rotor blades, and if you get in the wrong position, you'll actually sink into your own vortex rings, which basically it's like sinking into your own downdraft. When helicopters get stuck in this state, the rotor blades lose lift naturally because air is already moving down as they're trying to push more air down, and they can only do that so fast. You lose lift, and because helicopters are blowing exhaust up out of the turbines, typically into their own vortex rings as they fly, you also get in a situation where the engine is eating its own exhaust and it's losing power. So you're losing lift from the rotor blades and you're losing the power that your engines are able to generate. And this effect cascades. If you don't get out of it quickly, you'll just fall out of the sky and crash. So When you get in a vortex ring, it's really important, since you're already caught in your own downdraft, you can actually dump the collective in that situation. You want maximum lift, and you want to try to get away from your own downdraft. So you need to push in a particular direction. It almost doesn't matter which, but typically you'll want to roll left or right and then try to turn and get out of it aggressive. So when you're maneuvering a helicopter, we'll start from a basic cover. The main way that a helicopter traverses through the sky is not by generating thrust the way that a fixed wing aircraft will. Helicopters operate by manipulating their own lift. As I mentioned earlier, a helicopter is not generating, the rotors are not generating a constant amount of lift to their rotation. They're constantly changing the pitch of the blades, the angle of attack. When you raise the collective, you're increasing that angle of attack and generating more lifting power from the rotors. That also generates more torque at the center of the rotor shaft. So you'll notice when I increase collective power abruptly, rotor RPM drops. And when I reduce collective, rotor RPM will try to spike, but the engine's throttle system will automatically correct for that and reduce power to the rotor to keep it spinning usually around 280 RPMs. You don't want the rotor to spin too fast, or the rotor tips will break the speed of sound, creating an overspeed condition that is really bad for the engine and powertrain. So helicopters, we usually have some type of check to prevent this. But you also don't want the rotors to spin too slow, or they won't create enough lift to fly. So you'll note right here, I'm going to dump my collective, and you'll see how this physics actually works. This yawing force, this yawing moment the aircraft is realizing, is not something that I'm commanding. The engine eventually compensates for it, but for those few seconds, I'm spinning when I don't want to be spinning. And no matter pretty much what I do to the rudder controls to manipulate what the tail is doing, like I'm trying to counter steer, and the helicopter, it's not as bad, but I still can't keep the nose on target. This isn't a state you want to be in. When you're flying in combat situations, you need absolute control, which is also why we'll get into another mistake people make. Flying too fast in a helicopter is just as bad as flying too slow, because you're sacrificing some of your options to maneuver in exchange for a greater ground speed. I find that the chicane is most controllable around 200 kilometers per hour. When you're flying slow enough that the tail can actually command movement. At about 200 kilometers per hour, you can still rotate the tail and fly sideways like this. You're a little less stable, but with practice, you can do it. Now you'll notice as we're doing this, we're slowing down a little bit because we're presenting a wider cross-section into the direction of travel, so our wind resistance is going to make flying sideways kind of difficult. The chicane will want to settle around 150 kilometers doing this. If you try to tilt into your direction of travel and go faster than that, you're going to reach a point where the tail rotor can't compensate. Around 160 kilometers per hour, the helicopter is going to want to fly with its nose into the wind pretty much no matter what you do. And trying to fight that natural tendency is going to create issues with stability. You'll end up crashing or presenting your nose off target, and basically you'll end up getting shot or crashing somehow. So when I fly the chicane, I try to fly it low to the ground. I keep it around 200 kilometers per hour when I'm trying to fly straight, and that basically lets me face to any target that wants to threaten me, including a cheeky little interceptor that tries to get behind me. This is an example of a really powerful evasive maneuver if you're flying slow enough. I can immediately dump all my momentum, go from 200 to almost 0, and face whatever was chasing me. This is a great way to surprise somebody who thinks they've got you all lined up. If you've got the right loadout, you've got IRMS-1s, you can basically spin around and shoot your attacker in the face when they're not expecting it. So I'll go over how to perform some of these maneuvers, since what you're doing is kind of tricky. And it starts with, we'll call it level flight. Because helicopters fly by manipulating their lift, you basically have to throw the nose around to get the helicopter to move forward. And this is because the helicopter is basically balancing on its rotor. So if I'm flying like this, I'm going about 100 kilometers per hour. I'll trim the collective just a little bit. If I pitch down, notice how my nose drops and I start to pick up airspeed. This is where helicopters can behave like a fixed-wing aircraft. From a physics perspective, you can think of, in this situation, a helicopter as like a Cessna, where the wing is over the fuselage. If you pitch forward and you're not generating any thrust, you'll start to slide downwards and pick up airspeed. And the opposite is also true. If you level out the collective and then you pitch nose up about 5 degrees, you start to climb and lose airspeed. In this mode, a rotor is functioning a lot like a wing. But since we can change how much lift that our air quotes wing is generating on the fly, we can manipulate this effect to gain or reduce our airspeed. So I'm going to tip the collective up to 80% and nose down to about 15 degrees. Physically, the helicopter wants to descend like a fixed wing, as I was showing you, but our lifting force is actually counteracting this effect. So we basically slide forward through the air. Instead of relying on raw thrust like an airplane, we manipulate this lifting force to generate directions of movement. So I'm going to come off the collective a little bit, and I'm going to level out. We actually can't level all the way out because we're climbing a hill. And you can see that our airspeed starts to decrease. Now, the same physical forces you would expect from an airplane also kind of apply to a helicopter. If you go to corner, you will also lose airspeed faster, since turning increases your drag. We're going to come up to the top of this hill here. I'm going to level the collective out so that that helicopter would want to fly level if I had the nose flat with the ground, and then I'm going to pitch down, and we're going to naturally gain airspeed again. Helicopters can actually throw their lift around to stop faster. This is what I did when I demonstrated that sudden U-turn. We're going to basically do the opposite to slow down. We're going to raise the nose and we're going to drop the collective so that the rotor isn't producing as much lift, but it is producing drag. And you'll see, even though our vector indicator is level with the horizon right now, we're losing airspeed. This effect continues until we enter a hovering state, which you can see here. This is also how you can hover without using the automatic hover control, which I recommend everybody learn how to do. Auto hover is I'm not a big fan of it because it's a little lurchy, and it causes the helicopter to do things that you're not commanding, which means that you're not in full control of the vehicle. And that can cause you to make mistakes when you're under pressure, like when you're being attacked or when you're trying to set up for an attack that you know you have a limited window to execute. And you'll find the more that you fly helicopters, the more these physics start to make sense. And I could talk about this for hours. It still wouldn't work out for most people in their head until they actually sit in one of these things and practice. It's the best possible thing you can do. So going back to what I was talking about earlier, when you raise the nose and present the rotor into the direction of travel, with a low collective, you create an air braking effect that lets the helicopter slow down. You can think of it a little bit like a pinwheel. You put a pinwheel into the wind, and the rotor's natural tendency to spin is going to create a kind of a drag that you can use to manipulate your direction of travel. And this can actually be really extreme. So I'll show you again. When I go to do that maneuver, I'm going to only turn halfway, but to do that I got to slow down a little bit, so we'll get down to 200 kilometers. Then I'm going to turn sideways here and show you another interesting effect with helicopters is that they don't actually care what direction of the rotor is facing into the direction of travel. If I roll into the direction of travel, just as if I had my nose pitched into the direction of travel, I start gaining altitude. And here I'm going to start sliding sideways back in the direction that I was going. This lets you strafe back and forth as you move to attack a target. It's a useful tool to know, but it also demonstrates a physical principle that is important to understand. So I'm going to pick up some speed again. You can use this effect really, really quickly, but there are some trade-offs. For example, if I get going, got to get over the top of this mountain here. I'll show you one of the ways that this maneuver can bite you in the ass. You only have a certain amount of lifting force available at the rotors, and that means also you only have a certain amount of braking force at the rotors. So if you find yourself in a position where you need to stop suddenly, just dumping the collective and picking the nose up will only get you so far before you basically have to gain altitude in order to reduce your airspeed. And this can be a problem if you're trying to stay behind a hillside to avoid missile fire. So if you want to really slow yourself down without gaining altitude, to hard brake as you're traveling, you need to combine a couple of different maneuvers. I'm going to pick up airspeed again. I'm going to get going what I would consider the maximum, air quotes, safe speed the Chicane can fly and still maintain combat control. It's about 320 kilometers per hour. At this speed, you don't have very much yaw authority. So to get it back, you basically have to roll into the maneuver and then pitch hard so that you're presenting basically the belly of your aircraft into the direction of movement. So I'm going to show you here. We're going too fast for me to air brake quickly. I'm going to raise the nose, drop the collective, and then I'm going to roll and yaw at the same time. And just like that, we've turned around and even preserved a bunch of our airspeed. So we come out of this basically in our ideal maneuvering range, ready to face whatever is behind us or around us. And you can easily manipulate this maneuver so that you're not doing a 180, instead you're doing a 90-degree pitch. Think of it like a handbrake turn. Dump the collective, pull hard, and then as you come out of the maneuver, you raise your collective to snap the nose back on line, and then you're basically facing whatever it is you want to engage. Now, another important thing to know about the Chicane is that it's got a big enough profile. If you're moving too slow, a couple of nasty things start to be able to kill you. Let's say we were trying to attack something over the ridgeline, and a target that we don't see on our mini-map locks us with an optically guided weapon and fires. Depending on how close it is, you might not have any chance to respond. But ideally, you're not going to do what I'm doing and hover like this when you can see an enemy hostile on the radar. But some of the ground vehicles can launch AGMs, and a bunch of the light aircraft have them too. They're a useful tool to catch somebody who's not paying attention. But in this situation, you want to identify the direction the missile is traveling from, and just like you would with a radar-guided missile, you want to go hard. About as hard as the collective will let you go, and you want to accelerate. I like to get around 150 kilometers per hour parallel to the direction of approach. And if you do that, then very quickly you can evade an optically guided weapon. It's not too difficult. And with the Chicane, if you've got an ECM pod and flares equipped, pretty much all the long-range missiles are a non-issue as long as you're close to the ground. And the ideal would be 20 meters above ground level, but you can get even lower if somebody locks a scythe or a scimitar on you and tries to ping you from across the map. But when you're down like this, there's a lot of like the Ram 45 in particular, will often drop its lock on you if you just get low enough to the ground and assume even a loose notching position. Half the time you don't even need to worry about those. Really, it's just the scythe and the scimitar that are the real threats. If one of those gets on you and you're off the ground too far, unless you've got an ECM pod, you're probably going to get hit. The more comfortable you can get low to the ground, the more effective you're going to be at surviving, first of all, because you are an incredible pain to deal with in any of these online games. It usually takes a player who's set up specifically to kill you. And that's really, if you're fighting against a Chicane, any of the big fighters, they're kind of tough to work with because a Chicane can be packing IRMS-1 missiles, and it's got the rotary cannon on a turret mount that your NPC pilot will actually use to pretty good effect attacking aircraft that are trying to attack you. Whenever I'm playing in a multiplayer match, or even just against the local NPCs, this is the way that you should fly. You should pick a target set that you know you can engage, and you should keep low. Use the terrain, and you'll know I'm flying over a part of the map that's actually relatively flat. These are, you might call them rolling hills. None of the other aircraft in the game can take advantage of the terrain quite like the Chicane. You can see we're just kind of casually plugging along, but when you're doing this, the Spag and the Anvil tanks will not be able to target you very well because they need a line of sight to get a firing solution. They don't shell lob, even though I think technically the Anvil could. And means you can get really close to these platforms to engage them, which is great if you can catch them off angle because it takes a while for the turrets to spin and track you. But it's really bad if you happen to find yourself under their guns because you have basically no opportunity to evade them if they get a bead on you. You want to be close to the ground basically all the time. You don't want to climb and just be cruising at a higher altitude, and especially like if you're flying along a hill of this type and you know there are a bunch of bad guys a couple kilometers over on the other side, if at all possible, you do not want to pop your head up over the top of that hill and expose yourself. You can take machine gun fire from recon vehicles and MRAPs. The Chicane can absorb a lot of that kind of damage, but if a Spag or an Anvil gets even one good line on you and squirts you, you're going to be crippled. I haven't come away from very many encounters like that where the helicopter has been combat effective. You might still be able to fight, but you're going to be in a state where if you haven't used your ordnance, you're probably not going to be in a position to use it. You're basically going to be looking for a place to crash and survive, or looking for the nearest viable landing pad that you can get to and get service. So the last thing I'm going to cover, since we're kind of close to an airfield here, is going to be how to set up for landings. It has been my experience in general that hovered landings are a little bit too cumbersome for practical combat, especially the way that this game models logistics and resupply. It takes the War Thunder approach where you just have to park on the airfield in the general vicinity of a resupply truck, and your ordnance and fuel will magically appear in your tanks after a few seconds. So knowing that, you don't have to commit to land on the runway. The Chicane can land on the ground or anywhere around, and it has the advantage that the Cricket has where its landing gear isn't just going to fall apart on you if you roll across the ground for too long, so long as you're moving relatively slow. So we're going to come up to this airfield here, and I'm going to do a rolling landing like an aircraft. The main advantage to this landing is that you can see what's happening around you and you're not trying to control the hover and land on a pad. I have found that this is more consistent and it's actually faster in a lot of situations to do a rolling landing. But you have the advantage where you can come in way slower than any other aircraft, so you don't have to take up the runway in order to do this. When I come in and playing in multiplayer or solo, I'll usually pick a taxiway to land on, or a small concrete parking lot or something, and I'll just come in really slow like this. You can come in faster if you want, but for demonstration purposes, I'm just going to come in like this. I'm going to drop the landing gear, and I'll usually do that towards the end of my landing approach because I don't really care about air traffic granting me landing permission. I'll touch down and I'll come to a stop. After a few seconds, the supply truck will rearm you, and then you can pick up off the ground. I like to get on my landing gear as quickly as possible in a helicopter because most of your weapons are locked behind the safety switch and won't unlock until your gear is up. With a lot of the fixed-wing aircraft, you do have to be careful when you push the landing gear button because your flaps and your landing gear are tied together. Since helicopters don't have that problem, we can be a lot less judicious. So I'm going to show hovered landings, especially when you're coming in at high speed, can be a little trickier, but the same principle applies. You're going to have more success if you just don't get in a hurry. So we want to try to land in this square. You'll see I overshot it. So I got to pick myself around. I don't have, I don't think this game actually has the HUDs working yet where you can free look, but it's the same idea. You just have to take your time and watch your surroundings. I use the vanity cam a lot to orient myself when I'm doing this. But again, it's a situation where you just got to get into the helicopter and practice. The more you practice, the more intuitive this will feel, and you'll reach a point, whether you're on keyboard and mouse or using a flight stick and throttle like I prefer, there will come a point where this starts to feel intuitive. If you're on keyboard and mouse, I think that rolling landings are going to be just like they are with me and my HOTAS. They're going to be more consistent. You're going to have more control throughout the landing process, and your momentum will make it easier to abort, because obviously when you take off from a stationary position, it takes time for the machine to build momentum, and it makes it harder to escape if you get target locked as you're on your final. So that's going to be it for an introduction to helicopters. I will see about doing a follow-up here sometime soon where I get into some more advanced tactics, use some more missiles in some more complex situations. Anyway, that's all I've got for today. So if you made it this far, you probably liked the video. Be sure to show it with a click in the right place, and I'll catch you all later.